All right, let's take a look at our lesson for today. So today we're going to expand our work with area between curves, and we're going to look at curves that intersect more than once. So that's our goal today, is to kind of take this apart and figure out how to deal with these that intersect more than once. And so what I'm going to do, I love color coding. I know I'm strange, but I just love color coding. And so I'm going to the f of x, I'm going to make the pink one, and the pink one is the cubic. And so we would probably remember from our pre-cal or algebra 2 days that the cubic is the one that looks like this. So this one is the cubic. Then I'm going to make the parabola blue, and this is this one right here that's going upside down, just to help us kind of figure out what's going on. All right, so that's our coding right there. It says, our first part says, find x values of the points of intersection and label them from the smallest to the largest as A, B, C, and D. So we've talked about this before. How do we find intersections between two curves? What do? We set them equal to each other. That's exactly what we do. So let's do that. Let's do that work. So we've got 3x cubed minus x squared minus 10x equals negative x squared plus 2x. Now, of course, we're solving, so we want to, move everything to one side and make it equal to 0. I'm going to take everything to the left so that I can keep this leading coefficient positive. So let's see, we've got the 3x cubed. This is a negative x squared, so I'm going to add it over, and the x squareds kind of just go away. Then I've got this positive 2x. I'm going to subtract that over, so that would give me a negative 12x, and that equals 0. So then we want to factor. Let's see. So I'm going to factor greatest common factor, GCF, first. So 3 is common in both of these, and x. So that leaves me with, x squared minus 4. So what do we have? We've got, if I set each of these pieces equal to 0, I would have x equals 0 or x equals plus or minus 2. Those are our 3 intersections. Okay, and they want us to label them from smallest to largest. So we're going to label negative 2 as A, and I'm going to do that on the graph in just a moment. We're going to label negative 2 as A, and 0 as B, and 2 as C. So that's what they're wanting us to do. So let's go over to our graph, and let's do that. So this point right here, this point was the intersecting point A. This point right here was the intersecting point B. And this point right here was the intersecting point C. And so just so that we're aware, since I have labeled these, these are the labels right here. Now when I write my integrals, don't you love it when it jumps around like that when you don't want it to? So when I write my integrals, what I can do is just, did you see that too? Okay. I'm not losing my mind, right? That just keeps moving. Okay, well, you don't really want to go there. We'll try it 3 times. Maybe that's the charm. No, it's not. Okay, well, we'll just move on from there.
Try closing out of your window.
Maybe go which way?
No, maybe if you
Yes, the 4th time was a charm. Okay, all right. Okay, so now they want us to set up the integrals that represent the total area. And so as I was saying before this was rudely not cooperating with me, since I have said A is negative 2 and B is 0 and C is 2, I can actually use those letters on my integral bounds, and that is perfectly fine as long as I have, kind of said what they are. So let's look and see what we've got going on. I have, if you look at this graph, from negative 2 to 0, from x value of negative 2 to x value of 0, this first gray part, I'm just going to call this, we'll just label it, this is like section 1 or something. We'll call that section 1, and we'll call this section 2, just so we can tell them apart. In section 1, the pink one is bigger, right? Remember big minus little from last time? the pink one is bigger or the taller one. So I have to split this area into two different integrals so that I can, because the big one changes, right? This one right here is the big one. The pink one is the big one here. But over here, it's the little one, right? And then on the blue one for here, on this blue one, it's the little one. But then on this one, it's the big one. So they switch places. That's what happens many times when these curves intersect, is that the big and the little switch places. So that's why we have to do two different integrals. Okay, so our first integral we'll do, this is section number 1, we could say, or region 1. We're going to go from -2 to 0, and we want the pink one, which is, we're calling the big one on this one on top, which is the one I color-coded right here. It's that cubic. So 3x cubed minus x squared minus 10x dx plus. So we would, and they told us to just set these up. We don't have to actually calculate them. We're just setting them up. And then we want to add the second region or area. And this one is going to go from 0 to 2. Now this time the blue one is big, right? Blue is big is upper.
Why did you not subtract g of x?
Oh yes, I need to slide that in there. We need to subtract the g of x minus. And then our blue one was -x squared plus 2x dx. Okay, so that's our very first big minus little. The next one, we have to switch their places. The big one is the one that's higher up. Remember when we were going with respect to x, the bigger one is the higher one? Do you remember when we were going with respect to y? Which way is the bigger one with respect to y? Which way is the bigger one? To the right, to the right. So that's just something we need to keep in mind as we're working. So, but we're going with respect to x, which I know many of us are way more comfortable with. So we're going to go from 0 to 2. And the big one is the blue one, so that's the one that's the parabola.
Wait, I'm kind of confused on how to know like the difference between the big and the little.
Sure. So if we're focusing on just this, and I'm just going to get a ruler out. So what I want to do is I want to figure out which one is the taller one. In other words, which one has the largest y values. As we're kind of moving this along, as we look to see, the one that has the largest y values is actually in this part consistently the pink one, right? As I move this along. So if we look right here, you know, like this y value is bigger than this y value. I'm just measuring and determining which y value is the biggest.
Okay, and then it just stops at the last bound.
It stops here, right, because the pink one is no longer the bigger one, right? Now the pink one is underneath. And now on this side, it's the blue one is the tallest one, that has the biggest y value, and the pink one has the smallest y value.
Okay. Wouldn't that change after like the C intersection?
It does, but that part's not shaded. They don't want us to do that part. It's called unbounded. That part's unbounded. It's kind of wild open. So we're not doing, that's not the shaded part. Does that make sense?
Yeah.
Okay. So when we're doing this, just and as a side, if I go from, let's say, here to here, let's just look at this calculation right here. I just want you to see what we're doing. That would be like a y value of 1, right, minus a y value of -7. So that distance would be 8. So I hope you can see by the way that this is structured, we will never have negative area. Even though all of that, most of that is underneath the x-axis, it still shows, because we're doing area between curves, because it's area between curves, it's going to always show as positive. Okay, are we okay with that now? Do we understand why the big is on the top and the little one's on the bottom?
Yeah.
Okay. All right. So let's go ahead and put the integral, finish the integral for that second region. So we've got the blue one, which is the larger one in this case, comes first, then minus. The pink one is the smaller one, so 3x cubed minus x squared minus 10x dx. Now, they don't want us to put it in our calculator. They didn't ask us to. But I will tell you, if they did, I would put it in exactly how it looks, parentheses and all. I would not try to distribute and combine like terms, because knowing me, I would miss a negative or something. Something would go bad, and it's if you're doing a calculator, there's no reason to. Just put it in exactly like that. And that's what would calculate the area between those two curves. Okay, how are we doing? Everybody okay? Okay, we have one more example that we're going to, again, we're just looking at area between curves this time when we intersect more than once. So this example says, it shows us the graph of 2 minus 1/2 x squared. Okay, that's the, I'm going to color code it again. We'll just call this one the pink one, and that's this parabola. Okay, the parabola is 2 minus 1/2 x squared. And then we've got the line y equals 1, which we'll just put right here. This is y equals 1. And we are going from -2 to 2. So this is the x bounds that we're going in. That's what we're doing. Now, they were kind enough to shade that in for us. But even if they didn't shade it in, we should be able to tell, right, what's bounded between those curves. It's the, what they're doing is they're binding it in for us with the equations. The equations are like the boundaries of the curve. Okay, I'm going to pause there for a second. Are we okay so far? All right, so hopefully you can tell by the way that that looks is we really have 3 different regions to calculate. You see that? Because, let's just make this a little bit bigger. Right here, and I don't know what this intersection is, but from -2 to whatever this is, which we're going to have to figure that out in a second. Which one is the big one? The blue one, or the pink one, or the green one? The blue one is the big one, right? Okay, in this section right here in the middle, which is big? The pink is big. And then this, again, we don't know what this is. We're going to have to calculate it. In this section over here on the right, which is big over here? The blue, right? The blue is big. So this is going to require us to split it into 3 different integrals. Okay, 3 different integrals. And let's just label them. We would do, this is like 1. This one would be 1. We'll call this one 2. And this one is 3. Those are the 3 regions or areas that we're going to calculate. Now, before we can do that, we need to figure out what these intersecting points are. Okay, so we want to know where, when y equals 1 intersects with 2 minus 1/2 x squared. So let's do that. So we've got 2 minus 1/2 x squared equals 1. Okay, and I would, because I like positives, I would move this -1/2 x squared to the right so it's positive, and I would move the 1 over. I mean, that's what I would do. Of course, there's lots of ways to do it. You can do it however you want, but I like keeping that positive, so 2 minus 1 is 1. Then we want to isolate the x squared, so I would multiply both sides by 2. All right, so that would give me 2 equals x squared. Now we would square root both sides. So x is going to be plus or minus root 2. Okay, so apparently this over here, and why don't we just label it? So let's call this A. A is negative root 2. And we'll call this one B. B is root 2. Okay? And here, I hope we can tell that these intersect at -2 and 2. Right here. That's where the parabola crosses the x-axis.
Why would A be negative if area is
It's not the area that's negative, it's the x value.
Oh, okay.
Yeah, this is just the x value of that intersecting point. And this is just the x value of that intersecting point. Okay, so let's set up our work. Okay, so we're going to integrate, this is section 1, from -2 to, I'm going to write negative root 2, or you could write A, because we labeled it, it'd be fine. Big, which is 1, minus little, which is the pink one, 2 minus 1/2, oops, 2 minus 1/2 x squared dx plus. Okay, so this right here would calculate the area for that section 1. Okay, is everybody okay? All right, so the middle section is going to go from negative root 2 to root 2. And in that case, the big one is the pink one. So 2 minus 1/2 x squared minus, and the little one is the blue one, which was 1. Okay, so this is going to calculate the area for section 2. One more. That last section 3, we're going to integrate from root 2 to 2. And big would be the blue one, which I guess I should, come on, color code. This is the blue one. So it would be 1 minus, then the pink one is 2 minus 1/2 x squared. And this one would actually calculate section number 3. Okay, questions about that? Are we okay?